Welcome to this tutorial on CIVA Education UT module. The goal of this tutorial is to help you familiarize yourself with CIVA Education modeling software. It will go into a detailed explanation of simple cases relative to a beam computation and an ultrasonic inspection. Let's see how it works, beginning with beam computation. Thanks to the configuration wizard, it is possible to quickly define a configuration. Click on OK to start with the default beam configuration. Several panels are available. The first one, the specimen panel, allows you to choose between a cylinder and a planar specimen. Go on with a pipe with the dimensions shown here. In the Material tab, you can define new material properties for the specimen or keep the default carbon steel. In the Probe panel, you can adjust the crystal shape, the focusing, the dimensions of the wedge, and the signal's parameters. In the Wedge tab, the wedge angle will be modified to refract 60 degrees shear waves. The 3D view is automatically refreshed when a parameter is modified. Keep the wedge material as plexiglass. In the Signal tab, the frequency, bandwidth, and phase can be adjusted. In the third panel, you can define the positioning of the probe. Modify the coordinates of the reference point to move the probe. Now you can navigate in the Simulation Settings panel to define computation options. In the Option tab, you can choose the wave modes. In that case, transverse waves will be computed. The backward reflection modes can be computed by activating the Specimen's boundary reflection option and choosing the number of ultrasound skips. For this example, let's keep this option disabled. The dimensions of the computation zone are defined here, and the positioning of the computation zone is defined here. The orientation of the computation zone can be modified in order to match the beam's direction. Finally, you can run the simulation by clicking on Run. The results are displayed on the analysis page. If the beam is not displayed in the 3D view, you can display it by dragging it into the view. Now, let's take a look at the inspection simulation. Here, the weld configuration is available and will be chosen for our example. Select a linear phased array probe. Once you open the Inspection Simulation module, new panels are available to define the flows and array settings. The ray tracing display options will be adjusted to visualize a single ray and to better see the configuration. The parameters of the weld specimen are defined here: geometry, then material properties. The parameters of the array are defined here. The default parameters of the probe will be kept, 24 elements and 4 MHz. The defect will be defined in the Flows panel. The position of the flow is adjusted in the second tab. The flow is located along the bevel. Define the probe's positioning by clicking on the Inspection menu. Modify the positioning as shown. The probe scanning is defined by the following parameters: 30 steps of 1 mm. From the Array Settings menu, you can define and compute the delay low. Several focal lows are available. To inspect a 30 degrees bevel, a 60 degrees beam steering angle will be defined here. Do not forget to compute the low. Once you're done, the new angle is visible through the ray tracing, and the delays can be visualized in the Edit Low tab. In the last panel, several modes can be activated. In our case, we will only keep the transverse ones. The computation can be launched by clicking on Run. The results can be easily analyzed with the help of the reflection option. You can drag and drop the results in the 3D view to see both the flow and the B scan. The A scan is also displayed. Thank you for watching this video. If you want more information, please visit our website or contact us at contact@extend.com.